little bit about coastal flood defenses, and that's going to be very quick. And then we have 2 students that volunteered to teach you guys something today. So Jana, which she just sneaked out.
Yeah.
I hope she's not freaking out and regret it. And Seth, they will both each give a presentation. So Jana will talk about subdomain modeling, which it relates back to one application of coastal flood defenses in ADCIRC. So I'll give you a little spiel just to give you some background on what we're doing, and she's going to go with the hands-on exercise, and she also prepared a follow-up tutorial for you guys. So circle in that. And Seth did not have a tutorial, but he was going to walk you guys through post-processing. So how can we do plots and things like that without SMS? So hopefully we'll add to your toolbox these things now. So conceptually, we're not adding physics, so we're adding tools to your toolbox so you can, deal with this with more tools. So that's where we're going. So Jenna, I'll talk for like 10, 15 minutes and then you're up. Does that sound like a good idea?
Good.
All right. Just said all. Okay, so we know up to this point how to use our models to simulate storm surge along the coast. In last class, we used GIS to get these maps. Remember, so the blues are reflecting the water over the land. So we are very familiar with the modeling process up to this point. So what we will try to do today is, Jenna will go over subdomain modeling, and the end goal will be, what if we want to simulate coastal defenses? So what if we want to do something to prevent this? Or what if we want to use our modeling framework that we developed to test flood defenses? So I showed you guys, and actually everything that's here I've showed you before. We've seen this in the first week of class. Now at this point, this should be very familiar. At this point, this should be, yes, I understand everything that's going on here. I have my asymmetric, symmetric wind models, I'm running it. I have my ADCIRC, and waves will come 2 weeks from now. This is the only missing part so far, so we can close this loop. This will come in the 2-week class. Now, what can we do to protect ourselves against storm surges? Seawalls. You guys all seen seawalls? Have you all seen a seawall? No. Who has never seen a seawall? Anila, you've seen a seawall? Yes or no?
Yeah.
Where?
Wait, where?
Yeah.
I think I saw one in Peru.
All right, there you go. So that, fair enough. Yeah, they do have seawalls. Just putting you guys in the spotlight so you don't phase out. And I'm only going to talk for 5 minutes. Come on, stick with me here. Levees, walls that we build to prevent the water to propagate from one place to the other. Right? You've all seen levees. Should I ask someone else? Reza, have you seen a levee before?
I saw some in New Orleans,
There you go. Yes.
but that was like a while ago. Before
Yeah.
24.
There's in downtown DC. You guys, if you go see the Lincoln Memorial, there's the big levee there. Who has seen that levee?
Sure, I didn't notice.
Yeah, you're in
I don't
class.
think I recognize it though.
You wouldn't recognize. It's hard to
I've
recognize.
been there a million times, but I couldn't tell you. I couldn't picture it right now until I
There you go. So next time you visit the National Mall, you're gonna ask yourself, where's the levee that Dr. Ferreira kept talking about? And look for it and see if you can find it.
I've seen plenty of PowerPoint presentations with pictures of levees in them.
There you go. So that's it. Furthermore, there's now the flood wall that was just built almost in front of the White House. I think it's 17th Street and Constitution Avenue. Check for that. You guys never thought of that either. It's ready, it's there. So for those of you going in that direction, check it out. Sled barriers, those are huge. Those are usually to close a place where you have water flux. Beach nourishment. We do this all the time here. Very common in the East Coast. So we enlarge our beach area to prevent the water to get to the buildings. or you can move the houses themselves, or we can do a smarter way where we're adding multiple lines of defenses from bare islands to marshes to levees to elevated house, you name it. So you're being a little more strategic. And lastly, nature-based defense is where we're using marshes, artificial coastlines, and things like that to attenuate storm surge. Now, the reason I went through all that is to remind you what types of coastal defenses are out there. What we wanted to do with this class is how do we incorporate those in your modeling framework, which will boil down to Fort 14s and Fort 13s, which at this point should be very familiar to you. So think about your Fort 14. And in your head, not only the text file, you should be thinking about the finite element mesh with nodes and elements, which are representing the terrain, right? So let's say we have nodes here, and we wanted to include a levee. So levee could be just like this desk. So we wanted to change our Fort 14 now in order to have nodes that would represent the levee. So what you're trying to do there is you're going to change your Fort 14 in a way that it captures the topography of the levee. Same thing is true for a seawall. So you're literally changing your Fort 14 in order to capture that structure. So it could, if your Fort 14 is detailed enough, it's nothing more than changing elevation. But you might have to add more nodes in order to capture what you have. Right, so this is what we had. And if this is a plain topography now, you can change elevations. You might want to add more nodes in order to incorporate a flood wall, a levee, or something like that. If you want to consider wetlands, and she's doing the project on that, she's not here today. Maybe you're putting plants here. You're building a huge restoration project here. You might be changing your topography as well, so you might want to update your nodes, but you're also changing your friction. So you're changing your 13. So at this point, you're all able to incorporate flood defenses as much as you want in your project, because it's all about changing Fort 14 and Fort 13. How do you do that? You can do that with ArcGIS, like we did last class. You can do it with SMS. You can write a code yourself that goes into your Fort 14 and changes accordingly to what you're doing. Yes?
So if you were like thinking about like, oh, what if we put artificial reef and we sank a couple ships here for people to dive on, and how would that like maybe protect us? You would just go to Fort 14 and adjust the elevation at those points, right?
Yeah, so here's your shoreline, right? So here's the water.
Mm-hmm.
You're going to put the ships here.
Yeah.
Yeah, so you're changing it for, like,
You just change the elevation.
same thing for breakwaters. I've done a project once that we're studying breakwaters, and it's what we call submerged breakwaters or emerged breakwater, and which one is better. So, then you keep testing heights until this thing, how high you want to go, and then, yeah, that's where you're changing. Yeah, perfect example. If it's a flood wall, it's something like here. So you're changing your Fort 14. Right? You look confused. Good? Okay. There's one thing to be careful here is, because there's a very steep change in topography, you might have to add several nodes. Because, there's too much of a change. Right?
Yeah, so for trying to model a seawall on that left grid, when we want nodes right to the outside of the seawall,
Yeah,
just
you
saying
will want
this
to
is
add
normal
nodes.
floor, and then it
Yes.
immediately spikes up.
Yes.
Okay.
So you wanted to build that up. Yes. And then you keep testing. That's why developing meshes is tricky, because then you're testing to see if your mesh is stable or not. And if what you're changing is, ruin the whole thing, or is it still working? Does that make sense? Okay, so that's the segue for Jonah's talk now, which is, if you think about the meshes we've been using, this is the Atlantic Ocean, it goes all the way here, Florida, Atlantic Ocean, Maine. That's the kind of size of meshes we've been using, so we can capture the hurricane that starts here and makes its way here, right? When we talk about this is happening here. Not even like smaller than this dot, if you put it into scale. Which means if you're testing design alternatives, like I just said, you know, I have a 1 foot wall or 2 foot or, you know, that wider and things like that. You need to keep running the entire Army Corps 3.4 million node mesh every time you change something. So to avoid that, there's a tool that's called domain decomposition that allows you to cut off an area, record boundary conditions in your surrounding area from a regional simulation, and then you can change things here and rerun only your little area based on that boundary conditions. There's one caveat here, is you want your region to be large enough that the hydrodynamics are not, you know, the changes you're making are not going out, and you want to be, the region has to be large enough that's containing itself.
How big is that?
You tell me. That's the engineer's feeling, decision, judgment, or you're going to look at it, things like that. Does this make sense, what I'm saying here? Are you going to give them a little background, or am I supposed
Yeah,
to?
I'm gonna do like a little
You are?
snippet of the NC State.
Okay, great. Okay, so